Hello everyone, welcome back to Techlearners. I hope you all are doing good. I'm here with another video in mathematics, engineering mathematics. We will learn today Cramer's rule. It is one of the very popular rule to solve simultaneous linear equations. So before we get into the method and formula of the Cramer's rule, let us understand the limitations of this Cramer's rule. So the first limitation is this Cramer's rule can only be used to solve for the linear equation of simultaneous linear equation system which is consistent and having unique solution. So we all know that a simultaneous system of equations can be consistent or it can be inconsistent. If it is consistent, then it can have two solutions. Either it can have unique solution or it can have infinite solutions. So we have three such type of simultaneous linear systems. So this Cramer's rule can only be applied for the system which is consistent and having a unique solution. So we cannot apply this for infinite solution system and for inconsistent system. The second limitation is that it is suitable for the system of linear equations which is small. Small means, let's say we have number of variables here 1, 2 and 3. So it is suitable for variables which are 2, 3, 4 and so on. But it is not suitable for a very big system of simultaneous linear equations. Now let us see what is the Cramer's rule. So we all know that in this system, let us consider that this is a simultaneous linear equation system. a1x plus b1y plus c1z is d1 and so on. We are having three equations. This system can be represented as ax is equal to b in the matrix format, where a is the matrix of coefficients and x is the matrix of variables and b is called the matrix of solutions. So here a will be a1, b1, c1 in the first row, then a2, b2, c2 in the second row. Similarly, a3, b3, c3 in the third row. And then we have three variables x, y and z. So this is x, y and z. This will be a column matrix. For the solution, we have d1, d2 and d3. So this is a matrix of solutions d1, d2 and d3. So let us understand what Cramer's rule says. Cramer's rule gives us the values of the variables x, y and z in the form of, let's say, x is always equal to dx by d, y is always equal to dy by d and z is always equal to dz by d. What is this dy, dx, dz and d? So it is very simple. Here d is represented as the matrix of coefficient. Here we can say this is matrix A. So this is A1, B1, C1, A2, B2, C2, A3, B3, C3. This is matrix D and we need to get the determinant of this D, this matrix. Here we will write the determinant in place of D. Then what is dx? So we can see here x is representing the first column. So the coefficients of first columns here is represented by the x variable. So in this D matrix, we will replace this first column by the solution values. That means a1, a2, a3 will be replaced by d1, d2, d3 and we'll get dx. So this will be d1, d2, d3. Rest will be same. d1, c1, b2, c2 and b3, c3. This is dx. Similarly, dy. We can see the y is represented by the second column. So we will replace the coefficients of second column by the solution values. So here this will be a1, a2, a3 and now this d1, d2, d3 will be replaced by d1, d2, d3. So this is d1, d2, d3 and then this c1, c2, c3 will be same. c1, c2, c3. Now let us see what is dz. In the same fashion, we can see that dz, z is represented by c1, c2, c3. We will replace this third column by the solution values. So this will become a1, a2, a3, b1, b2, b3 and now this is d1, d2, d3. So we have got all the matrices. We have got d, dx, dy and dz. So just by dividing the determinant dx with the determinant d, we will get x. Then by dividing determinant dy by d, we will get y. And then dividing this determinant dz by d, we will get z. So just to apply the Cramer's rule, we had the limitations. Here, let us understand the limitations. For this, b, that means determinant of d should not be equal to 0. This is only applicable whenever the determinant d is not equal to 0. That is why it is only applied for the simultaneous linear equations which have consistent and unique solutions. Now let us take an example and see how we can solve the system of linear equations using Cramer's rule. You can see the first equation is x plus y plus z is 6, then 2x plus y minus z is 1, minus x minus 2y plus 2z is 1. So we can represent this in this form. Let me replace these values by the coefficient here to obtain the coefficient. So this will be Here we can say this is 1, 1 and 1. So this will be 1, 1 and 1. Here we have 2, 1 and minus 1. So this is 2, 1, minus 1. Minus 1, minus 2. Here we have minus 1, minus 2 and we have 2. The variables are x, y and z. So this is x, y and z. The solution 6, 1 and 1. So here we'll have instead of d1, d2, d3 we have 6, 1 and 1. Now we need to construct these matrices. We need to construct this matrix D. So for that we will have the coefficient matrix here. So this will be 1, 1, 1, 2, 1, minus 1 and this will be minus 1, minus 2 and 2. So this is the coefficient matrix. In this second matrix, the first column will be replaced by this solution. So this will be 6, 1 and rest will remain same. So this is 1, 1, minus 2, this is 1, minus 1 and 2. In the second one, we will replace the second column and rest will remain same. So the first column will be same. This is 1, 2, minus 1. The second column will be replaced by solution. So this is 6, 1 and 1. The third column will remain same. 1, minus 1 and this is 2. For the last matrix, we will have the third column replaced by the solution matrix. So first two columns will remain same. This is 1, 2, minus 1. This is 1, 2, minus 1. Second 1, 1. Minus of 2 and third one would be 6, 1 and 1. And now we need to find out the determinants of these matrices. So let's get the determinant of this first one using the first row. So this determinant of D, this would be equal to, so this is 1, so we have 1 and then we'll have the cross multiply 1 into 2. So this will be 1 into 2 minus 2 into minus 1. So this is how we get the determinant using expansion using the first row. Then we have minus of 1. And inside the bracket we have again cross multiply. So we'll have 2 into 2. Then we have minus 1 into minus 1. Minus 1 into minus 1. So we simply, if you do not know how to expand this, so we take each element in the row and then we hide this column, then we hide this row, and in the remaining part we'll perform the cross multiply by applying the minus sign in between. So we'll have the third value. This is 1. So we'll hide this row and this column. We are left with 2, 1, minus 1 and minus 2. We'll perform cross multiply 2 into minus 2, minus sign in between, minus 1 into 1. So now this will be plus 1 and now this is 2 into minus 2. So this is 2 into minus 2, minus sign in between, minus 1 into 1. So we have minus 1 into 1. So now we need to solve this. Let us solve this. So this is 1 into 2 into 1, that is 2, minus 2 into minus 1, that is a plus of 2, plus 2 and minus of 2, that is minus of 2. So this is 2 minus 2. Now next is minus of 1. So we have 2 2s are 4 here and then minus 1, that is plus 1 and minus 1, that is minus of 1. And the last one we have plus 1 inside 2 into 2 minus of 4 and then we have minus 1 into 1, that is plus of 1. So we can see here this is 2 minus 2, that is 0. So this will be 0. 4 minus 1 3 and minus 1, that is minus of 3, and here we have minus 3 and plus 1, which we have minus 3 plus 1, that is minus of 3. So we have minus of 3 here, so it is minus of 6. So the determinant, that is D, comes to be minus of 6. So it is not equal to 0. So we can proceed further and we can get the values of dx, dy and dz in the same manner. So let us calculate dx, dy and dz. Let us calculate dx. For dx, we need to get it into 6 and we perform cos multiply 1 into 2 minus 2 into minus 1. Then minus 2 and this will be cos multiply 1 into 2 minus 1 into 2 minus 1. This is plus 1. Cos multiply 1 into 2 minus 1 minus 1. This will be 6 over 2 minus 2 minus 1 plus of 2 plus 2 minus this minus and minus of 1. This is 2 minus plus of 1. And this is plus 1. 1 minus minus of 2 and minus of 1. So we have this will be 0 minus 0 0 0 plus minus 3 we have minus of 3 minus 1 minus 3 we have minus 3 minus 6 we have minus of 6. So we look at the taking values of whatever value. So D is minus of 6. Dx is also getting minus of 6. Now let's calculate dy. So dy will be 1 into cos multiply 1 into 2 minus 1 into minus 1. Then minus of 6 cos multiply 2 into 2 minus 1 into minus 1. Then plus last one is 1. 2 into 1 minus 1 into 1. Okay, so this is 1 into 2 into minus 2 and this will be plus 1. Minus of 6 2 plus 4 minus 1 is plus 1 then plus 1 2 into 1 minus 2 minus 1 is plus 1. So this becomes 2 plus 1 minus 3 4 minus 1 minus 3 and 6 is minus 3 2 plus 1 minus 3 plus 1 is 3 plus this becomes 3 is minus of 5. So you can see dy comes to be minus of last value dz. So let's calculate dz in the same way. So this dz will be this is 1 cos square 1 minus 1 this is 1 minus 1 then minus of 1 and then we have cos square 2 into 1 minus 1 last one that is plus of 6 so we have cos square 2 into minus 2 minus of minus 1 minus of this will be 1 2 1 minus 1 minus 2 minus plus 2 then we have minus of 1 minus 2 minus minus plus 2 plus 3 minus 6 then we have 2 plus 4 minus of 4 and plus 1. So this will be 2 plus 3 1 that is 3 2 plus 3 minus 1 minus of 3 minus 4 plus 1 minus of 3 minus 3 6 that is minus of 80. So dy comes to be here is dz comes to be minus of 18. So we have got all the values. We have got d, dx, dy and dz. Now we can simply calculate the values of x. So here we can see x will be dx by d. What is dx? Minus 6 I d. What is d? Minus of 6. So this becomes 1. Then we have y. What is y? dy by d. What is dy? Minus of 12. And d. What is d? Minus of 6. So this will be 6 2s are. So y comes to be 2. Now z. This is dz minus of 18. And d. What is d? Minus of 6. So this is minus of 6. And z comes to be, this is 3. So here we can say we have the solution that x is 1, y is 2, and z is 3. So this is our solution to the given system of linear equations. If you like my effort, then please subscribe the channel, like the video, and share it with your friends. Thank you so much.